Before starting this video, let me tell you that if you have any doubt regarding this problem or any other problem of the lead code contest, so if you can ping me up on Instagram, even you can join my Discord server. I provide both the links in the comment section. I'll pin them. So in this video, I'm going to discuss the find the maximum number of marked indices which occurred in today's lead code challenge. So it is a very simple problem. It is stated that you are given an array and you have to find pairs of I and j and mark them such that nums of I 2 into nums of I is lesser than equal to nums of j. Okay. Now see, this equation simply tells us that we have to use a two-pointer concept, right? The two-pointer concept, that is, I will be pointing at one position and j will be pointing at one position. Okay. In spite of giving it I, let's give it a better number, left and right. Okay. Left will be pointing in one position and right will be pointing in one position. Now, a very important thing, since it is stated that I and j, after finding I and j, we have to mark them. That is, we can't use it anymore. Okay, we can use it only once. So this is a very important thing. So we know that if we can use I and j only once, that means what is the maximum answer possible? The maximum answer, like the maximum number of times I can use I or j will be the total length of the total length of the array by 2, because we have to use it in pairs, right? So if I choose one from the first part and one from the second part, then only I can perform this operation. Okay, so what is the first concept of two-pointer? First of all, we have to sort the array. Okay, sort the array nums. Simple. Left is equal to what? We know that left is always equal to the leftmost element, I. And right is equals to what? Actually the rule of two-pointer is that right will be equal to n minus 1, right? But over here, we have to find out a greedy approach. Okay, not the naive approach. We have to find out a greedy approach. And the greedy approach states that you have to try to eliminate the right which is as low as possible, so that for the next number we can eliminate a bigger number. Okay, so that is what it means. So right will be like, let's say n is equals to nums dot length. Okay, excuse my handwriting, but like just get the concept. So n is the length of the array. Then right will be n by 2 if n is even, or n by 2 plus 1 if n is odd. Why? Because let's say there is an array and we have to divide it into two parts. So what is beneficial? If it is even, we can simply like divide it into two parts. But if it is odd, we can give one element over here also. Okay, so that's the basic thing. So right is equal to n by 2 if n is even, and n by 2 plus 1 if n is odd. And then the basic thing of two-pointer, while right is the condition, that is while right is lesser than n, and if arr 2 into nums of left is lesser than equal to nums of right, which is the condition that has been given, then we can say that left, we can increase the left by 1. Okay, we can increase the left by 1, and no matter what, we are going to increase the right by 1, no matter what. Okay, I'll explain you like how this thing works, and once we are done with this, we can return the number of element we have traversed in left into 2, because it is pairs. Okay, since the question asks that we have to return in pairs. So let's take this example, 9254. Okay, so after sorting, it was 9254 before sorting, and after sorting it becomes 2459, right? Where is left pointing? Left pointing over here. This is left. And where is right pointing? Right pointing over here. Okay. Now see, 2 into 2 is lesser than 5, right? So now left will be pointing 1 point over here, and right will also be pointing to the next element. Now see, 4 into 4, that is, 4 into 2, that is 8, is lesser than equal to 9. So that is also a valid condition. Now since this is a valid condition, but we don't go any further. Okay, we don't go any further, because if we go just one step further, right is going to be going this way. That is, it has exceeded the limit. So how many times did we access left? 2 times, which is left is now presently pointing at position 2, and because that is the number of times we have accessed the left, so since it is pointing at position 2, that is we have accessed 2 and 4, right? And correspondingly for 2 we have accessed 5, and for 4 we have accessed 9. So since this is the thing, so 1 into 1 plus, that is this 2 into 2, that is 4. Okay, like if you want for 3 5 2 4, after sorting it becomes 2 4, sorry 3 5 2 4, so that is 2 3 4 5, right? Left is pointing over here, right is pointing over here. 2 into 2 lesser than equal to 4, yeah, so left will be pointing over here and right will be pointing over here. 3 into 2 lesser than 3 into 2 6 lesser than equal to 5, nope. So now this is not going to change its pointer, this is going to change its pointer. But since after changing this pointer there is nothing over here, that is it has exceeded this n limit, so we can say that since only one condition, right? Now see where is left pointing at 1, because only one has been considered. So 1, so we are going to return left into 2, that is 1 into 2, that is 2. See, the answer is 2. For 7 6 8, there will be one point at 6, and it is not possible. Okay, like if you go to the last element, it is not possible. So this is the basic thing. So this is the basic code, like this is the basic 2-pointer approach of this problem. That's it. Thank you.